Hello YouTube, welcome to another video, and this video is focused again on OpenShift multi-cluster. So as I said in my last video, I'm going to be focusing specifically on the OpenShift multi-cluster pieces, and there's multiple setups, there's multiple configurations, and I'm going to kind of bring this piecemeal because it's just quite a bit. So I'm trying to break it up over a few videos, and then what I'll do is I will associate them under a group of videos. For example, create a playlist, and then you can go ahead and kind of pick the pieces that you want and kind of watch the pieces that you want. What I'm also doing is creating the associated GitHub repos as well. And as you're watching this, it's kind of cool because it's a kind of journey as well. And so we're doing active development. There's active discussions going on with different organizations. If you're not on that list, I'd highly recommend reach out to me so I can make this code available, make sure that we capture in your use cases. And if you're in sales and you like this content, please share it with customers, set up calls, meetings, etc. with myself or the team so that we can kind of go through it. So standalone mode, again, is referring to a single CIS running in potentially what I would call my primary cluster. My primary cluster in this case is a 4.11 cluster, and my new cluster is a 4.13. And actually, I had to reinstall this cluster from the last video, and luckily I'm using IPI provisioning, and it's actually pretty simple. However, what I wanted to do is I needed to create in the second cluster, I needed to create a unique pod network, right? So what I and the reason for this is because it's the pods that are getting exposed, right? When I did node port, it didn't really matter that much because the nodes are unique, but now the pods, you cannot use the default installation, because the default installation is going to default to, and I'm going to show you in a minute what it is. I think it's like 10.128. I'll pull it up in a minute because I have it. And so I had to change the pod network. And so actually I did a lot of research. They don't make it easy, to be really honest, especially for a product manager like me. So to change the pod network, when you do the install, if you're using IPI, just go and create your install configuration. And from that install configuration, actually go in there and change the pod network. And I incremented that. And from there, it changed them. I tried to go in and change a few things before when the cluster was running, but I was unsuccessful. So I don't know if there's a way. I've reached out to Red Hat to find out if there's a way, but I honestly don't think so. So when you build a new cluster, it's really important that if you're going to be moving to a multi-cluster solution, when you build a new cluster, it needs to be a unique network. So let's go and take a look at kind of what that looks like. I've actually broken it up nicely for you, so you can actually really see it. So if we go into the home here, let's go look at the overview. You can see this is a 417, and I'll make this a little bit bigger. I am trying to make this bigger. I really appreciate your feedback. 417.11. I know that sometimes this text is a bit small, but just let me know if it's not big enough. And if I go into this one here, this here is a 413.1, brand new cluster, just been installed. And so you can kind of see here's the cluster information there. And I'll just increase this to 150 as well. So what is interesting here, I'm not quite sure how to find the information from the UI, but if you go to the command line, you can actually run this command called OC describe network cluster, and this is the default cluster. So right here, this right there, I'll make this even bigger for you folks so that you can actually see this. There we go. Let me just zoom it in another one more time. There we go. So as you can see right here, here is my cluster network, and that is the default. So default in 413, which is what I'm running, and I believe it's the same for 412. Just check. is ovn-kubernetes. This is a 411 cluster, so I had changed the default setting when I did the installation to use ovn-kubernetes. Ovn-kubernetes is a requirement for multi-cluster, so it's absolute must that you are using ovn-kubernetes with unique pod networks, because we're not supporting tunnels. So that's really important. No tunnels. So you can see right there, this is the default 10.128.0.0. And then what it will do is it will actually go ahead and create a /23 and then start to increment the subnets based on that. That's kind of how it does. So per node, it's going to basically increment. So /23, it's going to keep on incrementing that. Based on your network. If you really want more information about OVN-Kubernetes, message me. I was thinking about creating a video, or at least getting the OpenShift Red Hat folks to create a video, because it is quite interesting actually, about the whole concept of how OVN-Kubernetes works. But there is a video already on the Red Hat portal, or actually on Red Hat YouTube, that you can search for. So that kind of shows you, once you've done the installation, kind of what that looks like. Actually, you might be able to even maybe increase this MTU size, but be careful with that, because it uses Geneve from the interface itself, directly to the pod. So you might want to look at that architecture. So let's go and take a look at this one, and you can see here that I started with 148. Doesn't get more original than that. I just instead of 128, I went to a 148, and it increments that way. And so if we look at what that looks like from the network perspective, from the worker nodes, I actually broke it out quite nicely. So you can actually see, here's the two right there. I kind of give them for you, and then here's the list. So I kind of broke this out quite nicely. And so you can actually see, if I do in the 411 cluster, if I actually do an OC get nodes, you can see there's the 6 nodes. This default install. You can kind of install kind of many nodes as you want, and you're probably going to have quite a few nodes. And so you can actually see here that there is 129 for 172, which is the first worker. Second worker is 174, which is a 131 subnet, and the third worker node 177, which is a 10.128. So that's like almost the default network. And on the second side, it goes, see, you can actually see it there, 148, 149, 151. So those are all unique. And so that's what's really important here, because your pool members are going to be on big IP, and the most important thing is of course, big IP requires static routes. So the static routes are so important to actually get this working. And I'll talk a little bit about that in a second. So as we can see now, that we have our networks configured that are unique. We can see our different network stacks. The biggest use case here is obviously distribution of traffic. So this is actually really simple. I'll tell you kind of what I did here. So because it's standalone, the CIS needs the kubeconfig from this cluster. So what I did was, I actually went in and copied the kubeconfig here, and I actually moved the kubeconfig to this cluster. And so there's a kubeconfig in this cluster, and then what I did is I basically renamed it, and then I created the secret. So it's really that simple. And I used an SCP client to do that. There are many ways that you can do that. You can pull the file and copy it into the cluster. I'm going to leave that up to you to figure out what way works for you. But for me, that was kind of really easy. So what I did was, I pulled this file using like a secure copy, and I copied it onto the 411 cluster, and then from the 411 cluster I created the secret. So I created the secret, referenced that name, and so now you have that secret. And this is exactly the same as what you would do on your regular cluster when you export, or you use your kubeconfig file to be able to use OC or kubectl commands. It's so that the command line has access to kube client. And that's exactly what CIS is doing here. CIS is using kube client. So now what happens is that this CIS can actually access the second cluster. So once you've done that, CIS can actually access and subscribe to the informers. So it's specific services and informer information that you would need, and these are referenced in the services themselves. So that's where the subscription comes in. It actually comes in kind of like within the route itself and the service. So it's going to subscribe to that service, and then it can watch the informers, watch the updates, because CIS needs to pull these pod members, it needs to pull these pod members, which are big IP pool members that it will then post. So once you've done that piece, which was actually really simple, make sure you install the the RBAC in the second cluster, and here's the files, but you can always fall back on the GitHub repo. Go ahead and deploy your app. You can see my two apps are deployed. You'll notice right here I'm using cluster IP. So this is the cluster IP for these apps. What I want is actually the pool IP. And so let's go take a look at these applications on the actual deployment itself. So we'll go look at the workload. We'll look at the pods. We'll pull Cafe 1. So for example, here's a coffee pod. There's a mocha. There's a teapot. So there's three pods of each. Let's take a look here, and we can see it's coming in that subnet right there. So 10.129.3.156. That's kind of where this pod sits. It sits on that worker node right there. That's kind of where it comes from, and that sits pod subnet. So that would be your big IP pool member IP address. So that's what CIS populates on big IP. So it's really cool. Big IP routes directly to that pod. That's what's so powerful about this environment. There's like no overlays. There's no tunnels between the big IP and the pod itself. Now, that could be any service. So, for example, you could do a two-tier architecture, which is quite highly recommended, and using nginx. And I will record that demo with OpenShift multi-cluster and nginx. Maybe that's coming, probably not next week, but I'll probably do it the week after, because I think next week I'm gonna integrate WAF into this. So my big IP is is actually doing URL filtering, and now maybe I'll do nginx the week after. But let's see kind of what happens. So that is the pod IP. So let's go ahead and take a look at some routes. So we're using OpenShift routes because this is OpenShift. For Kubernetes, we'll use CRDs. Kubernetes is coming. We're actually working with a prime customer to do Kubernetes. Probably, I don't know, a couple of weeks away, but don't hold me to that. We're working on it actively. So we're going to focus on OpenShift for now. So you can see that there's no routes. So what I'm going to do is I'm going to go into my active cluster, and I'm going to go ahead and create some routes. So I have some non-secure routes, very simple. We can actually take a look here. If I go to the my GitHub repo, you got the OpenShift routes. Let's go to the OpenShift routes. Actually, let's go back here. And so we'll scroll down. I'll show you what the OpenShift routes looks like. Here's the repo. So you can just open this tab, and there's 3 routes. And yeah, let's go take a look at coffee. This is what's really important. See right there, that's the reference. There's the annotation that references where the cluster is, the service name. So it tells CIS kind of what to watch for. So it's a very, very simple route. We are using the extended route spec here. Like for example, there's no virtual IP configured here. All the virtual IP addresses are configured in the extended config map. So that's what's really important. Extended config map here is where the route is, which specifies the namespace, the virtual name, and it specifies whether you're doing some type of redundancy. So think of this as if you're doing gateway API, or if you're familiar with your gateway concept. This file here, this extended config map, is almost like that gateway CRD, except that we're just using config map for now. And this will we will adopt the gateway API functionality once it's a little bit more mature. But this has reached maturity, so it's very simple, very cool to work with, very straightforward. So that's kind of where the config map is. That's already loaded. So we'll go ahead and create those 3 routes. So let's go ahead and do an OC create -f. Let's create all 3 routes, so you can actually see the routes are created. You can actually see there is the API. So that's the AS3 based API on the back end. That's between CIS. It's updating those pool members on BigAP. So I can see that right away. It's picked up. It's pretty quick to pick up all of that information, update all of those routes. It's 3 routes. So in this case, there was 3 requests because they all came in at different times. So we'll look at OpenShift, and you can see here's the 3 routes. There's coffee, mocha, and tea. If I actually click on these routes, that's actually really cool now. In the previous video, it was node port, so you were only able to see my node information, and now here you can actually see the actual actual server address and the remote IP as well. So the remote IP in this instance right here, this is the big IP itself. That's the big IP's IP address, but you can see here is the pod IP. So let's go ahead and create one from each. So there's Mocha, and so here we're on 128. This one was 128, and so I might get stuck to the same node, just because of cookie persistence in this case, but maybe not. I 128 as well. Okay, so I need more clients to distribute traffic between the two. But if I go look at the big IP here, we can actually see here is the virtual. Let me open the dashboard, because it's actually kind of cool to look at the network map. And from this perspective, we can see advanced filtering here. We can click on this. It's actually kind of cool. So you can actually see the actual breakdown here. Now, what you'll notice is that there's actually 3 pods. So here's the 3 pods for coffee. Here's the 3 pods for mocha and tea, and you can see. Look at the breakdown right there. So you can see 3 from cluster 1, 3 from cluster 2. Now, what's really cool here is if I shut down one of the clusters, I'm gonna have absolutely like no disruption, no traffic problems there. You can actually see the connections are actually sprayed across 2 clusters. There's a current active connection there, so that's 1 cluster. But look at that. Okay, so it's all on the 1 cluster. But what I can actually go and do is I can actually, if I really wanted to start monkeying around with this, I could actually go into the 1 cluster and actually start to actually do some things here. So here we go. So this is the 211 cluster. So if I go into let's go ahead and just double check this. So I'll go ahead and try this. So go into the 411 cluster. And let's say, for example, I need to do some maintenance onto this cluster. So what I'm going to do is I'm going to go into my deployment. I'm going to go into my coffee deployment, and I want to scale that down to 0 pods running in this cluster. So I should see there, you see the API call. So what happened is big IP, it's already been updated on big IP. So CIS detected the change based on the kube API, made the update. And so we can see that right now. So let's go back, and you can see there's tea, there's mocha, there's coffee. Look at that address. It's 148. So traffic is actually switched across to the 2nd cluster. This is exactly what we want to see. This is the exact use case. So now I can have my developers work on that coffee application running in cluster 1. They can pretty much do what they want with it. I can bring that back online when I'm ready to bring that back online. And so now I'm 100% certain that I have kind of like availability based on my pods, and so you don't have to worry about the whole infrastructure, DNS, that kind of stuff. It's so easy. All I did was just scale down those 3 pods, and the traffic moved between the two different clusters. You can see it incrementing here. And if we go back to the big IP dashboard, if we see that here, you should actually start to see that the coffee here, if I probably got to refresh this. Let's see, where's the refresh on here? Let's go ahead and refresh the dashboard. You can see here's coffee, and there's active connections on 148. You see that it only has 148. It doesn't have the 3, because those 3 are not available. Those 3 are still here, but those 3 are not available there. If I bring them back up again, then it will redistribute the traffic. Now, of course, Big IP is going to maintain persistence, right? There's many different ways that you can keep connections to a specific pod. That's totally up to you. If you just want to spray traffic based on round robin, this could be TCP based traffic, and you could use an ingress controller in OpenShift. So if you go back to that diagram, that's where we get back to the better together story with Big IP and nginx. It works really well. It scales really well. And if you start to use this solution, you become kind of like more redundant, and kind of like you can kind of pick and choose and kind of add your clusters. So that's the demo that I have for you today. Let me just go back to the documentation. Here's Big IP. I just want to go back to my docs. So here we go. So yeah, that's the demo. You can see here in the documentation, you can kind of see the breakdown on the pods itself. So if you want actually go into Big IP, you can actually see the actual split pods in this instance. There was actually the three and three, the different pods here. So this is, for example, coffee. You can see three here, and here. So let me go to Big IP and kind of show you, because it makes more sense. So you can kind of see, here's my pool members. There's three. Okay, because there's only three. It feels a little confusing. There's only three because I have three here. So go to the virtual server, click on here. You can click on resources. You can see here's the actual Big IP itself. So you can kind of see there's the coffee pod, the coffee pool. So if I go into the pools, here's the coffee pool. The members, there's only 3 members here, because if I go to the main cluster, this is the cluster right here, this 413 cluster. But if I go back to this cluster, there's no pods running. So if I put this back to kind of how it was, I scale this back up to 3, you can see there's already the API call. So it's starting to pick it up. Those pods are starting to come online, success. So you can see here, there's 3 pods running. Big IP will automatically update this pools to be 6, 3, and 3. Yeah, back. So that's it. So I took my servers down for maintenance. They came back. Now I'm getting a pretty nice ratio from a load balancing perspective. Am I still stuck to 148? Yes, I'm still stuck. If I refresh this, what happens? Let's see. Okay, there's a cookie on this browser, so it's gonna stay there. That's kind of how it works. If I turn on no persistence, then I'll get a really nice spray of the load, but I haven't done that. So that's it for this demo. I really appreciate everybody watching, and if you like these demos, make sure you're subscribed. If you're not subscribed, please subscribe. It kind of really helps this channel grow. Of course, get a like button will help with this awesome algorithm that YouTube has. And so there are going to be more videos coming in the up and coming weeks. I've got so much content to talk about. We've got a lot of cool things coming. So if you have any requests, please send it my way. If you want more information about this OpenShift multi-cluster, please let me know so we can schedule some time, and have a wonderful day. Thank you.